algal production rate in water is high. Results from enclosure method and light and dark bottle method are not shown in the field condition. This result may be shown under the stress condition. Lake sewer is an eutrophic shallow lake with 6 meter depth. In summer, the algal growth is remarkable. The diurnal change of dissolved oxygen in the water were measured. Near the surface, DO concentration was always supersaturated. In the daytime, DO concentration reached over 200%. The condition in the night kept over 140%. Under this condition, oxygen in the water must be escaped to the air. DO concentration near the bottom was low. The effect of photosynthesis was small. By the light and dark bottle method, 24 hours DO change was measured in lake sewer. DO consumption in the dark bottle is respiration. The net production can be measured in light bottle. The gross production can be calculated. This concept and this equation are correct. However, there were big differences between light and dark method and DO stock change in water. Order difference. There is something wrong. In slow sand filter pond, algae grow well. There is downward current. The effect of photosynthesis appears in the filtrate. The passing time of water through the sand layer is only several hours. This water does not contact to the air. DO saturation reaches around 200%. DO concentration in the inflow water is almost constant. However, the concentration in the filtrate shows big diurnal change. And the partial pressure of oxygen in the bubbles shows also big diurnal change. High DO in the filtrate water after sunset is due to diffusion from the bubbles. The DO change in the filtrate is the result of photosynthesis and respiration. This is the net oxygen production. At the sunrise, the minimum DO is due to the respiration. From the max and the minimum in DO, we can calculate the PG, PN, and R. PG, PN, and R from the diurnal change are measured. The data were taken from 10 to 20 days of filter run during 2 years. The activity may be influenced to the temperature, radiation, and grazing pressure. Some amount of oxygen may escape to the air in summer. However, this is big activity. How much the real production is? We harvested all the floating algae. This is the real net production. This work was done during 11 days. The crop greatly varies depending on the climate condition. I measured 2 days diurnal DO change in the river. DO concentration rose up in the daytime up to nearly 130%. During the night, DO concentration kept on the almost equilibrium to the air. This was almost 100%. On the cloudy day, DO concentration was less than 100%. This means high respiration rate in this river. Gas exchange between water and air is big. From the DO change, we cannot estimate their real activity. Biomass method for the periphyton was tried. Initial increase rate was varied depending on the flow rate. Ceramic tiles placed to the mesh screen and set in an irrigation channel. The initial growth rate were almost the same until about 40 cm depth, but the equilibrium biomass in shallow depths was larger than the biomass in deep water. This difference may be caused by the grazing pressure. Growth experiments in different depths were done in summer and in winter. What about the real growth rate is in the riverbed? Gravels were cleaned up using the brush and replaced on the riverbed. The initial development pattern of periphyton on the clean stones are shown the logarithmic growth. From the initial growth rate and the equilibrium biomass, the gross production can be estimated. These PG values were so big. Overestimation or not? This is true or not? Results by light and dark bottle method are more than one order less values than non-enclosed method. Result of enclosure method may be the result under the stress. It is very hard to contradict common method. Please check my comment. Please check my trials.